Hello everybody, today I'm going to be covering the topic of absolute and conditional convergence in AP Calculus BC. This is unit 10, known as Infinite Series and Sequences in the Calculus BC curriculum. You may also be taking Calculus 3 in college, and this will also be in there as well. And so we're going to just jump right into it. And so here's an example of a series that you may have seen when you were doing the alternating series test. I think it's earlier in your book, so you might have seen this. So we got the series n equals 1 to infinity of minus 1 to the power n divided by n. So this series right here, as you guys might know, is convergent. But we want to find out if it is absolutely convergent or conditional convergent. And you might be wondering, what do those terms even mean? So I'm going to tell you how you can test for it, and that'll pretty much give you the definition. And basically, how you can tell if something is absolutely convergent is if its absolute value is also convergent. If the absolute value of this function, if this series is convergent, then the whole series is absolutely convergent. So we're going to try that right now. So we are going to get the absolute value of this series right here. So we're just gonna copy it number for number. So we got this right here. This is the absolute value of the series. And basically what's going to happen is what's going to happen is this -1 will be completely irrelevant. You guys will know that basically on the top it'll just be -1 plus 1 minus 1 plus 1. And you'll basically get 1 over n. And, Alright, so that's what you'll get when you take the absolute value of this. You'll just get 1 over n. You'll just get this, and you might recognize this as the harmonic series. And this will happen because this -1 right here, it'll get taken out because of the absolute value. And the absolute value won't really have an effect. You could write the absolute value here just for thoroughness, but it's really not necessary. Your teacher or whoever's grading the exam will pretty much get it. So here you have the harmonic series. Harmonic series, as you might know, is divergent, always. So that means that when you take the absolute value, it is divergent. But we know that this, the original series we were working with, is convergent. So this is convergent. When you take the absolute value, it is divergent. So what does this mean? This is a status that we call conditional convergence, or this is conditionally convergent. I'll write this down. Conditionally convergent. So we got this right here. This series is conditionally convergent. So this series specifically, it is convergent, but it is only conditionally convergent, meaning if you take the absolute value, it'll be divergent. Now we're going to move on to this series, which looks pretty similar, but it has a slight difference. That difference being that it is from n equals 1 to infinity, -1 to the power n divided by n squared. That's the difference that I was pointing out. And we'll just remove this. We'll just clear some of this up. We'll know that that's conditionally convergent. This is going to be, we're going to find out. So what we do the same thing. We take the absolute value, -1 to the power n over n squared, same series. I am so sorry for that shape. That shape is hideous. So we got n equals 1 to infinity. We got the absolute value of -1 to the power n over n squared. So, well, what does this give out? We're going to get out 1 over n squared. And we're going to have from n equals 1 to infinity. So this is what we're going to get right here. And once we know that This is a form of this thing called P-series. And P-series, we take it by this exponent here, which we use the variable p. And if p is greater than 1, we know that it is convergent. I won't read the whole thing. And if p is less than or equal to 1, we know it is divergent. So, this 2 is greater than 1. That means this is convergent. So convergent, we know that this is convergent normally. This is normally convergent. Now we took the absolute value. We also found out that this is also convergent, meaning that this is under the distinction of absolutely convergent. So that is what we got here, and this is going to be absolutely convergent. So I'm going to clear this up, and we're going to go to our next series. This series right here, it goes from n equals 1 to infinity. It's minus 1 to the power n times 2 to the power n. I'll put a little times here just to make it easier for you guys. And when we have this, we know that 2 to the power n is normally divergent because of the geometric series test. And basically it's that if this power the base here is greater than or equal to 1, that means it is divergent. We know that this minus 1 will also not make a difference as well. So this whole series right here is actually going to be divergent. So we know that it is divergent. And when we can say that the original series right here, this original series is divergent, we don't even need to test it for the other one. We don't even need to put the absolute value to test it because it'll also be divergent. And when they're both divergent, that means you will know that this is completely divergent under every single condition. And that is that. And one thing to note is that you won't get a series where the original is divergent, but then the absolute value is convergent. When you take the absolute value, when it's divergent, it's always going to end up being divergent. When you have this as convergent, you will have to actually test it to see if it is divergent or convergent, because that will either fall under absolute convergence or conditional convergence. I hope this video helped you guys. Thank you for watching. Please leave a like and be sure to subscribe if you haven't already to this channel. And once again, thank you guys for watching.